everyone, welcome back to our channel. In this video, we'll study about the discovery of electrons. Okay, in our last video, we have seen the introduction about the structure of atom. Okay, in this video, we'll see about the discovery of electrons. Electrons are the major subatomic particles of atom. Okay, discovery of electrons. The study about the electrons, it was started by the scientist named as Michael Faraday. Okay, Michael Faraday started his study about the electrons with evacuated tubes. Those are called as, we call them as cathode ray discharge tubes. He took the cathode ray discharge tubes to study about the nature of electrons and the presence of electrons in the atoms. Okay, we'll study about that experiment. Here he took, as I said, this is a cathode ray discharge tube. Okay, this is a glass tube. You can imagine like you have seen the tube lights, right? Tube lights are made up of glass. Like that, this is also made up of glass, and which is a glass tube, and here it is vacuum, and it is filled with gas, like lighter gases. It is filled with hydrogen gas. Okay, and here two metal plates are attached at the two ends. Okay, these are the two metal plates. Okay, and this metal plate is attached to the negative end of the battery. This is the battery, and this plate is attached to the positive end of the positive terminal of the battery. Okay, so this is attached to the negative terminal, and this end is plate is attached to the positive terminal. Okay, and this metal plate which is attached to the negative terminal is called as cathode, and this plate which is attached to the positive terminal is called as anode. Okay, now we have two plates, two electrodes. These metal plates are called as electrodes. Okay, and they are supplied, or they are connected to the battery. Okay, this is the cathode ray discharge tube. Means here it is the initial setup of the experiment. Okay, in this what he did is he applied voltage here, and when he applied the voltage, the electrons or the particle starts moving from cathode to anode. Here one thing we have to keep in our mind, that we have to apply very high voltage. Here voltage applied is about 10,000 volts. So this is very high, right? So whenever we apply very high voltage like 10,000 volts, the current starts flowing through the wires and the electrodes. Okay, so when he applied a very high voltage of 10,000 volts, then he observed some particles started moving from cathode to anode. Some rays are moving from cathode to anode. And how he got to know? Because these rays are not visible to our naked eyes, right? And how he got to know that the rays are passing from cathode to anode only? Why they can't pass from anode to cathode, right? Chances are there, right? Only he can see something is moving in the discharge tube. But to confirm that that is moving from cathode to anode, what he did, he coated this surface near the anode with zinc sulfide. Okay, he coated this surface with zinc sulfide. What is zinc sulfide? It is a fluorescent material. What do you mean by fluorescent material now? fluorescent material is the one which glows or which illuminates whenever any kind of ray or the radiation hits it. So when the ray starts moving in the vacuum tube, the fluorescent material starts glowing. Okay, so when it glows, obviously when the rays comes and hit it from the opposite direction, when they hit like this, then only it glows. Okay, if it comes hits here, because it will not glow, because here we have glass. So now we got to know that the rays are coming from cathode to anode. Okay, when cathodes are rays are coming from cathode to anode, then only the fluorescent material glows. By the glowing of this fluorescent material, that is zinc sulfide, we got to know the rays are coming from cathode to anode. Okay, now what we got to know from this experiment, some rays are coming from cathode to anode, that is from negative end to the positive end. Okay, then again he did another experiment by taking electric and magnetic fields. By this experiment, he got to know the charge of the electron. Okay, now we got to know that electrons are passing, means electrons are moving from one end to another end. But we don't know what is the charge of electron. To get to know about the charge of electrons, he did another experiment. Okay, we'll see that one. Next one is, he did this experiment. This is also the same like glass tube only. Here also he took two metal plates. One is cathode and another one is anode. They are connected to the high voltage supply. Okay. Here also he coated the surface with fluorescent material, and now he made some changes. Now we want to know the charge of the electron. Okay. So for that what he did is, he applied two electric plates, means with the electric field. These are the two plates to which he applied the electric charge. So these are the electric plates which gives electric field. Okay, so here the rays are coming from the cathode to anode. Okay, when he applied the electric field here, what he observed, the rays started deflecting to this point. This is the A point. Okay, the rays started deflecting to the A point. A point means here the rays are started deflecting to the positive end. Okay, and the thing, one thing what we have to know is, like charges repel each other and unlike charges attract each other. Okay, like charges means if you take two positive charges, they repel. Okay, and if you take two negative charges also, they repel. But if you take one positive charge and one negative charge, they attract to each other. This is the basic concept what we have to know before going to this experiment. Okay, now like charges repel each other and unlike charges attract each other. This is what we know. Now now the rays started deflecting to the A, that is near to this positive charge. So they are started deflecting towards the positive end. Okay, now what he did, he removed the electric field. Now he gave the magnetic field. Okay, this is the 3D structure. I can't show it on the board correctly, so you just imagine. Okay, this is the magnet. So he applied the magnetic field. Now also what he observed, the rays are coming. Rays comes till here, and when they experience the magnetic field, they started deflecting in this direction. Call it as B, point B. They started deflecting in the C direction. Means here also they started deflecting at the positive end of the magnet. And when he removed both magnetic field and electric field, he observed that the rays traveled in a straight line. Like how what we have observed in our last cathode ray discharge tube. There we didn't apply any kind of fields like magnetic field and electric field. There also the rays traveled in a straight line, like that only. So here, whenever we don't apply any kind of fields, what he observed? He observed the rays of light, the rays of electrons, they traveled in a straight line. So by this observation, what he got to know? Here, the electrons, the rays are deflecting towards the positive ends. When they are deflecting towards the positive ends, what you can observe means, what you think, the charge of that particle that is moving, it should be negative, right? Because if it is also positive charge, then it will not deflect towards the positive, because positive repel each other. So if it is going to the positive end, means it should be a negative charge. So by this, he comes to the conclusion that the electrons are negatively charged. Okay, by this experiment, what he got to know? He got to know that electrons are negatively charged. These are the experimental observations made by Michael Faraday to know about the subatomic particle, that is electron. He discovered the electrons with the cathode ray discharge tube, and he got to know the charge of the electron, that is it is negatively charged by this particular experiment. Okay. After these all experiments, he gave some of the properties of these electrons. Okay, we'll see those properties. These are the 4 observations which are drawn after the experimental study about electrons. Okay, what is first one? First one, what it says, rays starts from cathode to anode. Here, rays of electrons starts moving from cathode end to the anode end, that we have seen, or we have already seen in the experiment. Okay, they starts moving from the cathode end to the anode end. Okay, the next one is rays themselves are not visible. Of course, whenever they did the experiment without the fluorescent material, they cannot see the rays, because they are themselves, they are not visible. But when we use any of the fluorescent material, then we can accurately tell that the motion and the direction of those rays. Okay, and the third one is, in the absence of electric and magnetic field, they travel in a straight line. This we have seen in both the experiments. In the absence of both electric and magnetic field, they simply travel in a straight line. Okay. Then last one is, characteristics do not depend upon the material of the electrodes and nature of the gas. This is very important. Here, characteristics of the waves, of the rays of electrons, that do not depend upon the material of electrodes. We have taken two materials, two electrodes, one is cathode and the another one is anode. If you take the electrodes of any metals, there also the electron starts moving from cathode into the anode. Here, the characteristic of those rays, that will not depend upon the material of electrodes and the nature of gas. There, what we have taken the hydrogen gas. If you take any other gas also, their characteristics remain same. And they did this experiment by changing the position of electron, and by changing the material of electrons, and by changing the gas also, but they have observed the same thing, that is the rays move from cathode to anode. Okay, these are the 4 observations what are drawn after the experimental studies of electrons. Okay, this is about the discovery of electrons. Okay, in our next class we'll study about the charge of the electron, and about the protons and neutrons. Okay, again we are left with other 2 subatomic particles, those are protons and neutrons. Okay, about those we'll see in our next classes. Okay, about this class, if you have any doubts, you can ask me in the comment section. Okay, have a nice day. Bye.